We're nearly done building our Solidity smart contract for performing flash loans on the Binance Smart Chain using PancakeSwap V3 and PancakeSwap V2. However, we still have one small component to do on the actual Solidity smart contract, and that is to repay the actual flash loan. Not only that, but the most important part is to pay ourselves. If the arbitrage is profitable, we want to pay ourselves whatever balance is left over so we get to keep that profit. That's the whole point of this in the first place. And so we're going to finish off quickly building that function. And then we need to step into our testing here and mimic an actual whale's wallet. And so we're going to find somebody, it could even be yourself, it doesn't have to be a whale, but it could be somebody's wallet that has some BUSD. We're going to take that BUSD, fork the mainnet, because we've set up our Hardhat to do that, and have it transfer some BUSD onto our smart contract to ensure that there's enough funds to pay back the flash loan so that we can actually see if this would work in a real world example. So we're going to clone a wallet. We're going to send some fake arbitrage funds to the smart contract to mimic as though that arbitrage was successful and provided us with excess returns, and then perform the arbitrage swap. And so this section here will nicely complete testing if indeed our Solidity smart contract is fully working. So let's head over here to our code and begin coding. And we will finish, as said here, with our repayment of the V3 flash loan. And so let's go down here where we are performing our trades. And then after our trades, we have a note here for repay the flash loan. And that is what we need to go and code up now. So what I'm going to do is just create some space here and start writing the code for that. So if the fee 0, so we know that there would be a fee if we use token 0. So it's the same thing as saying, you know, if there was an amount for token 0. So if fee 0 is greater than 0, then we will do the following. We will say transfer helper dot safe approve, and we're going to approve the address here of token 0, because if the fee 0 is greater than 0, then we're going to use token 0. And it's going to approve it for this address over here to send the token 0 dot balance. So balance of, and the balance of that we're going to be using is the balance of this address. There we go. So the token 0 balance, whatever this contract is holding, will be approved to send over to our token 0 address here. So there we are. We're going to save that there. And then what we need to do is actually do that transfer. So here we're going to say token 0 dot safe transfer, and then open and close parentheses. And this now will be the address of the pool, because that's going to be here our recipient. And this will be the decoded dot amount 0 and plus the fee 0. So that's actually what we're going to go and pay back over here. And so here we could console log at this point. So we could say console.log, and we could say token 0, and that here will be the address of token 0. So that'll tell us, you know, what the address is. So if I could just type that out there, and we can also console.log token 0 balance. And therefore we would say, instead of the address here of token 0, we'd say token 0 dot balance of, and then address this. So we can print that out there and then say token 0 dot safe transfer, because now we've paid back the amount that we borrowed plus the fee. So who do we need to pay now? Most importantly, ourselves. So we're going to pay decoded.caller. This is important. Don't pay the message sender. The message sender is the smart contract that has called this Pancake V3 flash callback, which is essentially the pool address. Remember, we discussed that before. So now we want to pay the caller, which we passed into the initial request. The initial flash loan request is going to be the caller. The caller was message sender from this function, which is different from the message sender for this function. That's very important. Make sure to pay attention to that. And then here, the token 0 dot balance of, and again, it'll be the address of this. And so there we go. So what we're doing here is we're approving for the full amount of whatever this contract holds. And then the remaining amount here, we are sending to our caller here, the remaining balance of this token.0. So whatever prints out here, which is still remaining, will be sent over to ourselves. So that's brilliant. So if it's not token 0 we're working with, then it's token 1. So here we can just say, instead of fee 0, we can now assume that this is going to be fee 1 greater than 0. And so anywhere we have token 0 here, we can now replace that with token 1. And so just make sure that you're replacing absolutely everything with the 0 reference here. So this will not be 0. This will be 1. This here will be 1. This will be 1. All of this is 1. And so token 1 dot balance of. And so token 1, now we want to safe transfer that token 1. And that is literally our smart contract completed over here. So that bit is now done. And we can run npx hardhat test. It will fail because it's probably not profitable, this flash loan opportunity. So let's just see. It might work for you. If it does, you got extremely lucky. That has happened to me before. If it does, though, you got extremely, extremely lucky. And there we go. The contract has been deployed and it's now performing the swaps in the transaction. And as expected, this has failed nicely. So if I scroll to the very top of all this jargon here, and you'll see that it says here, BEP20, transfer amount exceeds balance. And so transaction may fail or require manual gas limit. BEP20, transfer amount exceeds balance. This means that we're trying to transfer more than what's actually here in our contract. And so we can't do that because what that means is our arbitrage was not profitable. Now there are one of two things you can do at this point. The first thing that you can do is try to search for a profitable arbitrage opportunity and use that token and those exchanges with that V3 fee and the amount that you think is profitable and test it. It might just be profitable. Or you can do it the way that will work every time, which is go and deposit onto the smart contract a nominal amount, so an amount that'll make sense. We'll talk about that in a moment. That will be left over because you initially deposited it onto the smart contract to force there to be enough funds as though the arbitrage was profitable. But now how do you do that? Because you need from the forked mainnet an actual blockchain account which does have the funds that you're trying to interact with. In this case, it's BUSD we're borrowing. So we need some BUSD actually on the smart contract. So how do you actually go about doing that? Well, the way that we do it is we mimic an account. And Ethers and Hardhat makes this really easy to do. So we will find an account that actually has funds on it, mimic it, and then transfer a balance onto the smart contract and run this again. So theoretically, our actual flash loan smart contract in Solidity is done. Like we're good to go with that. But now we need to go and interact with it to prove that it's good to go. Head over to BSC scan and just type in BUSD and search here for a token that will have some kind of balance on it. So here, if you click on holders, this will give us a list of whales that are holding an enormous amount of BUSD. So for example, I'm looking for one that looks like an actual address, and I can see this one is an address. It ends in D60. So if you see this one, maybe use this one. It's the one I'm going to use. This might not work for you straight away. So you can try a few different addresses. And this is the part in the code where you just have to understand what's going on so you can troubleshoot if you do get an issue here. But this is the address here that I want to use. And so I'm going to click on this over here and just copy this address. So let me go here and copy that and head over to my code. So here under the test, flash test, I'm going to scroll right to the top and I'm going to create another constant here and I'm going to call this whale address BUSD, and that is going to be equal to this as follows. And you know, that whale address also should really have some WBNB or some BNB in that address as well. That would also be useful. But nonetheless, this is the account that I'm going to roll with here. And now what we need to do is actually go and create a function that will go and mimic that whale address. So above this initial describe, or below the initial describe and above this one, I'm going to put a function here. So this will be an asynchronous function, and it's going to be called create_whale, open and close parentheses. And then here's where we're going to write our function. So we'll say const provider is just going to be equal to ethers.provider, like such. And then const whale balance, not what balance, that should say, sorry, whale balance. And that's going to be equal to await provider.get balance. And the balance for who? Well, the whale address BUSD that we've put up here above. And so that is going to be our way to get the balance. And here we need to write an expect. So I'm going to expect that the whale balance is not equal to 0. If it's 0, we have a problem and I want this code to fail. If it does fail for you, select a different account and keep trying until you get one that has an actual balance in it or reads that it has a balance in it. And so now we need to impersonate whale account. And to do that, here we can go await network, which is imported here from Hardhat, dot provider dot request, open and close parentheses, and within that put an object, so curly braces, method, colon, and this here we will put Hardhat, all lowercase, underscore, impersonate, and the spelling must be perfect here, so impersonate account with a capital A for account, comma, and then params is just going to be here within an array, whale address BUSD. And so that is going to allow us to impersonate that whale's account. And so here we can say const whale wallet is going to be equal to ethers.provider dot get signer. So not get signer with an S on the end, just get signer, not get signers, get signer. And then in there, whale address BUSD, and then expect that the whale wallet dot get balance, open and close parentheses, dot not dot equal, again, we don't want it to be equal to 0. Just to prove that this is all working, we're writing those checks in there. And then what we want to do is ensure that there is a BUSD balance. So this right now is making sure that there's actually just a balance on that whale's account, and that when we impersonate the wallet, there's still a balance, but that's not actually the BUSD balance. That'll just be the BNB balance, which is the native token for the Binance Smart Chain. So here we want to ensure BUSD balance. And to do that, what we're going to do is say const ABI, because we now need an ABI to connect to essentially an ERC20 type function. And our speech marks here, we need double quotes for putting in a string. And so what is that going to be? Well, let's go over here to our contract and let's take a look over here. We've got decimals, we've got balance of. And so this function, balance of address account, and then view returns uint256. I'm just going to copy this and I'm just going to paste it in here, because the cool thing with ethers.js is we don't need an entire ABI. We can just type in just the function we need. And the address here, I'm just going to put here as _owner, because this is how I've done it before. And rather than have external, I'm going to just call it view returns. And then here uint256, and I'm going to say balance. So this is just some code that'll work, an ABI that will work. Get rid of the semicolon on the end of that. This is just an ABI that will work for connecting to an ERC20, which will be our BUSD. Put a semicolon on the end of the closed square bracket over there as well. And so here what I'm going to do is say const contract. We're now going to connect to the contract. BUSD is going to be equal to new ethers dot contract. Just like we did before, except this time we know what the borrowed token is going to be. Our borrow token is going to be BUSD. So let's actually put that here, const, and here I'm going to say, borrow token is going to be equal to BUSD, just so that that's clear. And let's just take a borrow token and put that in here. And then we also need the ABI, which we've just created, and the provider, which we've also already got. So that's great. And here we can say const, and this will be balance BUSD. And in fact, that should be USD up here, is going to be equal to contract BUSD dot balance of, like that, whale address BUSD. And so what we're doing now is connecting to the ERC20 token for BUSD, and we're saying, okay, how much does this person have of that BUSD? And then again, we can copy this expect over here, expect whale wallet, or in this case, we're actually just going to say balance BUSD. We can remove the dot get balance is dot not dot equal to 0. And then we can return output. So here we can just say return, and in curly braces here, we'll just say whale wallet. So we've proven that there is some BUSD for that address, and therefore we can actually just go and return that wallet. So how do we actually go and now create this whale whenever we need to within any describes like we have down here? Well, now it's actually very easy because we're bringing in this load fixture above here. We're going to do it down here. So we're going to say let, and that's going to be not create whale. Sorry, this is going to be whale wallet to be equal to await load fixture. And in there, we'll pass in the create whale like that. Now this await is expecting an async function, meaning I put it in the wrong place. Let's put it here within this .it deploys and performs flash load arbitrage. This is an asynchronous function. So I'm just going to pop it in there. And now it is available within here. So here is our whale wallet. And earlier we created this signer. I'm just going to comment that out. And I'm going to use the whale wallet now as the signer for this contract as well. So let's also just go over here and console.log our balance BUSD. So let's console.log balance BUSD whale, and just make sure that we see something print out over here, just so that I feel comfortable and you feel comfortable. It's all working. So let's correct the spelling there and go npx hardhat test. That has failed. Let's have a look at why that might have failed. And I think I can see the reason why. This is saying D56. That is BUSD. So for some reason, I've copied in the BUSD address here, when what I was supposed to copy was my whale account address, which is this address over here. So this is the address I was supposed to copy, not the address of the token, the address of the whale. So there we go. Sorry for that. That should have corrected that. Now let's go and run this again and see how that's looking. And it says its promise is pending to get that balance BUSD. So let's actually go here and go await to get that balance and try that again. And there we go. I can actually stop that from running. Let's scroll up past the flash loan smart contract errors, and we can see the value here. So yes, indeed, it agrees that there is a balance for this whale over here. And so that's perfect. That's all I needed. And in fact, what I'm going to do here is just put in a wait within that too, and just to run that again and make sure that's all working as well. Excellent. So just stop that from running before the flash loan goes and throws that error. And you can see indeed this is still working. So I'm going to remove that console log from there. We know that this is actually pulling that whale balance and that address, and we've printed it out, which is great. So now we can actually use this whale wallet to do some pretty special stuff. And so what do we need it to do? Well, we actually need it to go and pay some money towards our flash loan smart contract so that we can pretend like there's enough funds in there for an arbitrage to test this working more in a real world type of scenario. And so up here, I'm just going to create some space and I'm going to say send BUSD for fake arbitrage calculation. Smart contract should then work. Okay, so what do we need to do? We need to say let USD amount, capital AMT, is going to be equal to ethers.utils.pass units, just like we did before. And then in speech marks over here, we're going to decide on the amount. I'm just going to put 20 BUSD into the smart contract. And again, BUSD has 18 decimals. And so I'm going to pay that into the smart contract, and then I'm going to copy this ABI code over here. So we need an ABI, so I'm going to copy that down there. And I'm going to add another set of quotes here with some function information. So I'm just going to type it out for you to save us going back and forth between screens. I'm going to say function transfer, open and close parentheses, address, _2, and then comma, uint 256 _value. And then that is going to be close parentheses afterwards, public returns bool for Boolean, and it's going to return a success variable like that. And there we go. So now we have a more extended ABI that we can use for connecting to our smart contract. So here we're going to say contract USDT that we now need to connect to is going to be equal to new ethers.contract, open and close parentheses, borrow token, which is going to be our BUSD, the ABI, and our whale wallet. And so what does this mean now that we have this contract? Well, this means that we're connecting to the actual contract of BUSD. I'll put in here USDT. I should just put BUSD, pardon me. And now that we're connecting to that contract for BUSD, we can go and say const transaction transfer, or TFER, BUSD is equal to await. And that's going to be contract BUSD dot transfer. And we're going to transfer to our flash loan address. So here, flash loan dot address. We're going to transfer the USDT amount here. In fact, here I'm just going to say const USDT amount. And I'm going to transfer that amount here. And then here we can say const receipt TX BUSD. And that is going to be equal to await TX transfer BUSD dot wait, open and close parentheses. And then here we're going to expect, open and close parentheses, the receipt for the transaction BUSD dot status, and here dot to dot EQL, so it's equal, open and close parentheses 1, meaning we expect that this transfer actually goes through. Now let's also just print out to make sure that that is also on the flash loan contract itself. So here I'm going to say const, and we'll say contract bal for balance BUSD is going to be equal to await, and that'll be contract BUSD, and that is going to be dot balance of capital O, open and close parentheses. And here we'll put the flash loan dot address. In other words, how much does this address have in BUSD? That's what this is doing. So it's saying, take our flash loan address for our BUSD contract and just store that in a variable called contract balance for BUSD. And here we'll just say console.log, and we'll call that wallet BUSD. And here I'm just going to put some \t, just some tabs here to tab across. And in fact, there's probably too many. Let's get rid of that. And here we'll put the contract balance B USD over here as we wanted to. So great. And we know the whale has also had that BUSD. They've now taken that BUSD because here's the whale wallet that we're using to do the transfer. We're transferring some of it into our actual smart contract, our flash loan smart contract. And so that's what we're doing over here. Now we've got our amount borrow, we've got our routing, we've got, which fee we want to use. We could choose a different one. But here we're going to just play around using the 500 fee break over here. And now we should be able to go and execute our flash loan smart contract fully. And so what I'm going to do here actually is I'm going to copy this code and first of all call this before the flash loan. And let's print out what the BUSD balance is after the flash loan. So down here, we're going to call this after. And here I'm going to call this after and print it out over here. Now let's go and run npx hardhat test, and it's failed. It says here reverted with reason string F1. So I must have done something wrong. Let me go back here to my flash loan, and you probably spotted this. You're probably laughing ages ago at me. This here is not meant to be fee 0. This here is supposed to be fee 1. And we know it's token 1 we're borrowing here. So this was really important to get right. Clearly we didn't pay back the correct amount. Let's run npx hardhat test again and see what happens here. So far so good again. And does it win? Yes, it does. It went through successfully. Now let's actually have a look at what happened here. And let's go back to our JavaScript code as well, just because that's what we've been working with. So here we can successfully see we have our flash loan pool address, which was calculated before when it was deployed. We have our fee 0 because we're not borrowing any of the first token. We're only borrowing WBNB, and here's the fee that we were charged for that. We have our base token, which is BUSD, and we've borrowed this amount, 30 BUSD. And then we're swapping here this token, which is our cake, and we're getting that amount of cake. Then we're swapping cake for WBNB, and we're getting that amount of WBNB. Then we're swapping our BNB back for BUSD, and we're getting that amount back. And then here we have our token 1, which is our BUSD, and that's the balance before we go and transfer it back to ourselves, in which case after we've done that, the balance BUSD after is 0. Now notice up here, the balance before was 20. And the reason why it's 20, remember, is up here, I sent 20 BUSD to the smart contract to pretend like that's the amount of arbitrage there might have been. If I put in here 10, it might not be enough. It might now fail because I'm into the negative because it's actually negative arbitrage. No, 10 is still enough. Let me put in 5 and see if 5 works over here. And does it work or does it fail? Yes, it still works. Let me put in 1 BUSD ahead of time to see if that will be successful. And yes, it now fails, meaning that the actual arbitrage transaction did not make profit. It actually cost us more than 1 BUSD. So it was not profitable. So in here, if I put 0 and let's pretend this was successful, that would have meant that the arbitrage transaction was actually successful. And so just to keep this working again, I'm going to pop this here back to 10 and I'm going to go npx hardhat test. And there we go. This should now work. And there we go. That has worked absolutely perfectly. So you have successfully proven that you can pull a whole smart contract together that does an array of things. It, first of all, is able to extract a flash loan from the liquidity on PancakeSwap V3. So you now know how to get liquidity for doing flash loans on the Binance Smart Chain. It's super cool. And you know how to perform swaps on 2 exchanges. In this case, again, we use PancakeSwap V3. You didn't have to, but we did. And PancakeSwap V2, which are the most 2 widely used liquid exchanges on the Binance Smart Chain at the time of recording this, by a mile. By a mile, they're used a lot there. And so now you know how to do that. You also now know how to interact with the smart contract. But right now, this is all happening on our own local machine. We're forking a mainnet. It's not actually yet on the blockchain. And so in the next session, what I'm going to show you how to do is to now deploy this to the blockchain. So let's go and do that with mainnet in the next session. See you over there.